This is the next video of this AC motor drive series. Here we are going to see how the speed can be controlled for an induction motor. We come across the advantages, limitations, operations, speed torque characteristics. Now, the speed torque relation, speed equal to 120 into F divided by P, I have already discussed. F is your frequency and P is your pole. And torque, the formula is torque. For varying the torque, for varying the starting torque, we can vary either the voltage or the resistance, particularly rotor resistance, and the impedance, Z square. And the relation between speed torque is also given as torque equal to 3 into P by omega, where omega is the speed in radians per second, therefore omega is nothing but 2 pi F. And voltage can be expressed as 2 into pi into F into torque into the flux and winding factors. KW is your winding factors. You may the pitch factor, distribution factor goes on, right? Therefore, for varying the speed of an induction motor, we can either vary frequency or we can vary poles in the stator side, whereas we can vary the rotor resistance in the rotor side with the help of a power electronic converters. For the rotor side, again another very important topic comes into picture. It is your slip power recovery schemes, where we can regenerate the power. Slip power can be recovered and it is given to the battery or given to the supply. Particularly the slip power recovery is utilized for the all electric vehicles, EV. For the stator side, stator voltage control is also there. You mean with the help of an voltage regulator. The very good application is your ceiling fan voltage regulator. And let me see the first frequency control technique. For frequency control, for the low frequency operation, if we, in order to vary the speed as per 120 into F divided by P, and as per the formula V is equal to 2 pi F into T into pi into the winding factor Kw, the flux is proportional to V by F. After this derivation, we know that the flux is proportional to V by F. Therefore, for the low frequency operation, in order for the induction motors to be run at very low speed, we have to decrease the frequency. If the frequency decreases, then, and we are keeping that the voltage as constant, the flux increases. We are keeping that the voltage as constant, 230 volt AC for a single phase. In order to decrease the speed, we are going to decrease its frequency. The flux increases. Since the formula is flux is proportional to V by F, the flux increases. Whereas the flux increases for a certain limit and gets saturated. Therefore, frequency decrement method is not possible for a long speed variation because the flux gets saturated. Let me consider the another end. For increasing the speed, we are increasing the frequency. Again also, if the frequency is increased in order to increase the speed, right, we have to sacrifice the performance of the induction motor. Since the flux decreases. If the flux decreases, we know the operations of an induction motor. If the RMF flux decreases, then the performance have to be sacrificed. Performance get affected. Therefore, frequency alone can't be utilized for varying the speed for a large extent. Please make a note of it, for a large extent. Therefore, we can vary V by F techniques, the voltage and frequency technique, in order to vary the speed. And see here the graph for varying the frequency alone, which is shown here, and frequency alone, again it is shown here. For when V by F ratio is maintained, then it is called as the below speed, and the V by F, V is maintained constant, then it is above base speed. Above base speed. The base speed may be 1500 rpm for a 4-pole induction motor. The graph, the relation between Vf and speed torque characteristics is shown here, the left hand side, and how the speed has been changed from lower level to upper level is shown in the right hand side of the graph. By increasing this frequency, how the speed is changed. And with this, let me move on to the next chapter, where we can discuss about voltage alone and this V by F control. Thank you.